right, time to get started on biology. I'm going to put under the camera here what I would normally give you at the beginning of our unit, and not for you to write down, but just to give you a framework of the kind of things we're going to talk about in this unit. If you do have your textbook, is the very first unit in your textbook. It's got blue as the tab you can find all the pages on. And so we're not necessarily going to do these things in this order, but I just want to show you really quickly what is on the list here. It looks a little blurry. You can zoom in a little bit there. Okay, so one of the things we'll do is talk about mitosis and why it's important within your body. We'll talk about how cells specialize. You might not know what that means yet. And then how they organize themselves to become organs and part of bigger organ systems. We'll talk about how these systems work together. These things are sort of a general introduction, and if you're going to take biology next year, then you will see these things again in a lot more detail. They're going to show up again next year and build on whatever we can get done this year. Here, as we're going through, most of the time as we're talking about when things are working properly and everything is going well, how we've learned that by way of abnormalities or what goes wrong when there's disease. So I'll try to make those connections ongoing because it sort of becomes a natural part of conversation. When you're talking about healthy, you tend to talk about unhealthy at the same time. And then we have down here the two last points is we're going to talk about medical imaging technologies and public health strategies, as well as ethical issues related to the uses of technologies. So once we talk about what we can do within the field of biology and some new emerging technologies, techniques, and things like that, there's ultimately ethical issues. Those are things that challenge our moral code. People feel very strongly whether things, even though we can do them, should we do them, or do they break some sense of what we feel is right and wrong and go against our belief systems. So this is always just purely based on your beliefs, and there's not really a right or wrong. It's more of discussion points. So we'll see how far we can get with that, given this kind of forum we're working in. What I've decided to start with for today is to talk about medical imaging. And the reason I'm starting with that is because we just came off optics. So this is where optics and biology overlap, or one of the places they overlap. We'll also talk about microscopes. And so I will try to draw on some of the things we talked about in optics and pull them over here so you can see how all the different types of sciences eventually start to blend together. So how chemistry and biology, physics and biology, physics, all those things, as you learn more and more about each one, you start to see their connections with each other and the benefit of having a bit of background in all of them. All right, so today it's mostly going to be note-taking, but I'm going to try and keep the note itself relatively brief and just do some talking as we write down some stuff. Okay, so I'm going to put that to the side. I will also possibly shove the textbook under here every once in a while to show you some pictures. So for example, medical imaging, that's chapter 3 in your book, if you want to read into this part, they open with stuff like this. Okay, so some very colorful images that were taken. And what's unique about this, of course, or special, is you're getting images created of the inside of the body without actually looking inside the body. So we're going to talk about how they generate those images today to learn more about what is going on and to look for abnormalities or to look for disease, because that's usually why you're getting those tests. You're not getting them when you think everything is just great and everything's running smoothly. You're getting those tests when you think something is wrong, or you know you've had an injury and you're trying to investigate the extent of that injury. All right, so today's note is called medical. Am I on there? Yeah. Medical imaging. Okay, and we're going to do so as kind of like a chart format today. So we're not going to cover all of the different kinds. We're going to make a list of some of the types of ways you can get images of the body, the inside of the body, or a look inside the body, and then a few, maybe one or two of their main uses, and then sometimes some additional details, things that might help you picture these things or be meaningful to you, connect it some way to something you might already know. So let's do the headings of this table. I feel like, I'm going to zoom out a little bit just so I stay on my page. Okay, so we're going to call this types. We'll just call it type. Okay, the type of medical imaging is going to be our first header. And then we're going to go main uses. And then we're going to put additional for any other things I kind of want to add on or write a word or two to help put things together or make connections. All right, so the first one I want to do was the x-ray. Very familiar. All right. If we were in class, we would talk about, when you've had x-rays and what for and where and all that kind of thing. So you will know that most of the time, if you think you have ever broken a bone, they will use an x-ray to determine if there is a break or a fracture. So we'll write that down because that one might be familiar. Breaks/fractures in bone. And that would be at the hospital. So x-ray machines are not too hard to access in terms of a quick, reliable, easy to get access to type of test. They can also be used in cancer detection. So they're looking for tumors and things of that nature, which will show up in an x-ray. Especially if you're looking at, your lungs, like if you do a chest x-ray or something like that, you would get a blurry blob that they could then investigate further. They can also be used, like I said, so lungs already, heart, blood vessels, those ones might be ones you're less familiar with. And then I'm going to put on here, because even if you've never gone to the hospital for some kind of potential injury or a scan of some kind, you may have had an x-ray at the dentist's office. So cavities. So getting that internal view of your teeth and looking for any sort of decay or breakdown in your teeth. All right, so additional details in terms of all the ones we're going to look at. This is the most common. I don't think that would be much of a shocker to you. Okay, that it is relatively quick. It is painless. Okay, now you don't want to get x-rays all the time, and some people are extremely cautious about their exposure to x-rays. So some people within the dentist's office, for example, now refuse x-rays because they're worried about their exposure to radiation that comes with the x-ray. So we talked about the EM spectrum, the electromagnetic spectrum, when we started optics last unit, and x-ray was one of those ones along the spectrum, and the frequency was higher than others, and so it comes with damaging aspects to it. And so very infrequently or for specific reasons, the risk benefit, it could be worth it for you to get the x-ray knowing the risk is relatively low for that one-time use to see what has actually gone wrong with your bone, etc. But you don't want to be exposed to it ongoing, because all that damage would build up over time and lead to other issues for you within your within your DNA, things like potentially cancer, which will come up later. So that's why the techs who work with a lot of the techniques we're gonna go through here, x-ray being one, would not stay in the room. They remove themselves. That's why they cover areas that you don't need exposure to the radiation. So where you would wear like the lead apron or something like that, so that it blocks and doesn't allow it to penetrate through there. Okay, so high energy causes damage. Okay, we'll put 2 DNA, but like I said, it's relatively low risk, and so it's one of those things where you weigh the pros and cons and make a decision based on what is the best decision for you at that time. Okay, within x-ray, there's a couple other things that we're going to bring up really quickly. Sometimes before you get an x-ray, they will get you to drink like what's called a radioisotope, something that they can watch move through you, or sometimes some kind of like dye type thing they might inject. and that will allow them to watch something move through you. So they can take pictures with the x-ray to see with this injected dye, for example, what the blood vessel looks like. If it's open or if it gets pinched, there's a blockage, or if it's something moving through your digestive tract, to see, once again, if there's a blockage, if it's getting pinched and things are having a hard time moving through at some point. So there are some pictures of this in your textbook. So there's what we would associate with like a regular x-ray, right? You can see all the bones, and the trained eye would be able to identify if anything's out of place or if anything's got a crack in it or is obviously potentially broken into. Let's see what else I can show you here. Okay, more x-ray type features like we talked about. Chest version, so the lungs themselves look dark just because there's nothing for the like the waves to bounce off of. So it's the bones that get highlighted in these kinds of images. But if there was some kind of tumor or if a lung was collapsed or something like that, they could see that. And then this is what I'm talking about. Fluoroscopy, where you have that added piece of a dye. And so here they have, this would be the intestine. And so you can see this material moving through the intestine, and that would allow them to look for, like I said, blockages or pinched problems that might be going on in there. This is an angiogram. Okay, so we have looking at what's going on with the blood vessel. So this one, just to go back to this specific example, says this is a normal artery through to the femur. So that's what it should look like. And over here, this is a blocked one. So basically what's happening is this region isn't getting the nutrients it needs, and that is quite visible right there. Okay, the other use is the radiotherapy, and this is associated with cancer treatment. So there are situations where you actually want to damage cells because you want to kill those cells, and that would be a piece of potential cancer treatment. So if you're going to have radiation therapy, the idea is as you target all that high energy specifically into the area where the cancer cells are, and that high energy will do so much damage that will kill them. So it's obviously at a higher dose than we do just to see a scan, but with the intention of giving so much radiation that it damages the cells to the point where they die, and that helps eliminate the cancer. So usually used in conjunction with other things, but that can be one piece of your therapy that is decided upon as a course of treatment. Okay. So let's put here, we'll add to this one sort of another use. I'm leaving a line intentionally because I'm sort of separating it. Situations where you would have cancer treatment. And this is connected to this, okay, but to the extreme. Okay, so this one is intentional. All right, and you're taking advantage of that. And we did, I feel like I mentioned that too when we talked about the EM spectrum and the X-ray, and some of you chose to write about that, etc., as how it's been useful and beneficial to have that machine and take advantage of that. Okay, next one I want to do is the ultrasound. Okay, and you might be familiar with that one, also one you may have had for various reasons. So this one can be used in different situations. One of the more common ones you might be familiar with is pregnancy. So watching for the growth and development of the fetus as it's going through its different stages of development. There's also another common one you may be familiar with is to listen or look at the heart and investigate what's going on in there with valves and all those pieces. And another one is to do a biopsy. So if they're going in to remove something, they might use this imaging to make sure they go in and get it in the right spot. So ultrasound is all about using those waves and the bouncing off of those waves to get the image. So it's not a sharp picture. The one you've probably seen the most of, sometimes people when they're announcing that they're pregnant will share their little ultrasound photos. And your book does have an example of that. So a trained eye, right? You can go and get trained in all these imaging techniques and actually make a career out of it, be the person who administers the test, and then also knows how to read the scans and learn from them, because the trained eye cannot see everything. We have some different examples of using ultrasound and the images you get. So there's the fetus in there. You can see the head, you can see the spine, that kind of stuff. So it says here you can look for things like spina bifida, which would mean there's a defect or a problem in the development of the spine. They can also see the heart at the various stage, and obviously they can determine sex of the baby too and things like that. Now, whether or not they share that is a different story. But those are the kinds of things they can look at. Obviously, this is sometimes at the point where they realize there's not just one, there's maybe two, maybe three babies, whatever it might be, growing inside, and all those pieces. Okay, so you can see it's not sharp, it's not clear, but they can still get lots of valuable information from that without obviously being blind to the development. And then here, this is one for the heart. So an echocardiogram, or an ECG, you've heard of it that way before, is used to see, like I said, how the heart valves are functioning, movements, look for blood clots, those kinds of things as well. Okay, so once again, it's not a clear image, but to the trained eye, they would see like the different chambers of the heart. This has been color coded specifically, so they've added the color after the fact. You're not going to see color in any of these things in the X-ray or in the ultrasound, unless it's added, because a lot of the stuff is done now on a computer screen. So you don't necessarily get like a sheet with the X-ray. It's all imaged, which they can do at lower doses and stored digitally. Okay. So pieces to that. There's also some other types of scans you can do, like a CT scan or a PET scan. And so let's do one of those. Let's do computed tomography. That's the CT. Okay. I don't think anybody calls it by the other name. Maybe. And this one is used more for imaging your soft tissues or seeing what's going on in your brain. You might have heard of people, you may have had a CT scan of your head, maybe after potential injury or fear of concussion, things like that, possibly. So this can image bone, soft tissue, arteries, etc. Okay. Like I said, I'm going to put down here one of the main uses is to look for a bleed in the brain. Okay. This is usually more accessible than an MRI machine, which is going to come up next. So you might have different layers of tests. You might have more than one of each of these, but we're getting into the ones that are a little bit harder to access. So X-ray is the most common. Ultrasound is also quite accessible. I guess I should put over here. I didn't write any additional details. You just put in here if you wanted it uses sound waves. Actually, I'll add that for you. Uses sound waves. Okay, do that. For the pregnancy one of those pieces is that drink a lot of water beforehand if they're going to do anything in that area, and then it just helps with the imaging because of those reverberations and things like that with the sound waves. Okay. So what I'm going to put here is that you get, which is an advantage over the X-ray and is clearer than what you get with an ultrasound, is you get a 3D image. Okay. And you can see also cross sections, which means you can slice it up and look at like plates or thin slices of what you've got in there. So I'm going to show you some pictures just from your textbook. So something like this would be somebody's head, and so they've got the 3D, but then the computer will automatically slice it into thinner sections and then display it like this, so you can look at it like one layer at a time. Okay, and you get all that. All of these so far are quick. There's no pain. There's not a lot of prep to the test. And then we're going to do the MRI next. So I'm just going to show you that one at the same time. These are some images that you get from an MRI. Now, same thing, the colors are not there. Those are added. This is all computerized. So then you can highlight color for different features and all that. So you can see 3D imaging, really crisp and clear. You get an in-depth look at everything that's in there. Arteries, bone, muscles, cartilage, all that stuff, whatever it might be they're trying to look at. And then you can section it and look at it from different views and sort of get a much more holistic idea of what is going on inside there. So really quickly, we're just going to add the MRI. It's short for magnetic resonance imaging. I'm just going to call it MRI. Oh, right. Magnetic resonance imaging. Okay, MRI is how most of us know it. And I'm just going to put everything in terms of they can image so well everything that's going on inside. Now, these are harder to access, as you may know, than the others. So only if it's really required, I guess, would you get put on a list to get one of these. It's not local, so we can't access it in our community. You may have had to travel to get yours. They do them in the middle of the night, even because the wait lists are so long that you get your scheduled time to show up to get it. And some of them run 24 hours a day, 7 days a week. And that's when you go in to get your imaging done. Okay, but they're large and very, very expensive machines, which means it requires a lot of funding usually to be able to purchase such a machine, and access to it is limited. And so they just do what they can to get that. And this is the one you would think of as like the big hollow cylinder. So I'm going to draw it. It's going to look like a rainbow. But you've probably seen it in TV shows if you haven't been in one before. It looks kind of like this. They usually put you on a stretcher, put you in there, and then you're in there for the duration of the imaging. So they kind of put you in there. My understanding is there are open air ones, but most people who I think have had one done or have experienced this style here. Okay, it's a big magnet. So you don't feel anything once again, and they get all the inside scanning done while you're in there, and then they analyze it later. Okay, and decide what to do for your treatment after. The last one I'm going to do is called biophotonics, but we don't usually call it this. We call this when you go for a scope. And I feel like there's a picture here. Yes, there is. Maybe another picture back here. Maybe not. Okay, so I might find one later. But this one, it's the easiest way to get quick pictures today. And they're colorful. You can go, it's like a little camera, I should start with, like a little camera and a light that's on the end of this metal scope. It looks like a big metal chain, like a snake, and on the end is a camera and a light. So they can get a look inside you by going like down your throat. And so this is, I believe, what's happened here. This is the view of the bottom of the stomach. So it's been inserted in the mouth, and then it's traveled down the esophagus and into the stomach to take a look around. You can also, if you get a colonoscopy, what they've done is started at the anus and then same thing, but gone up that way into the intestines and follow the intestines to take a look around to look for, like the word says, problems in the colon, which is your large intestine and anything that might be going on in there. Okay. So anytime you see scope, that's what they're talking about. If we're not talking about like not cutting into you to use it, so either going in the mouth or up the anus from the other end, they can use it in surgery. So if they're actually going to make an incision, let's say in your abdomen or something like that, they can insert it there and take a look around as well and assist with the surgery, whatever they might be doing. But that's what this is. So the way that I just wanted us to write it down is it's commonly used to look at your digestive tract. So like I said, in through the mouth or up through the other end, but that's all the same long tube. So it just depends on what region of the tube you want to look at. You can access it. It's just whether you go up or whether you go down to get to where you want to look at. And the other time it would be used would be in surgery. So you've made an incision somewhere else and you're using it to go in and take a look around. Instead of just cutting it all open, you insert that and snake your little camera and light around to see what's going on in there. And really it's just a light and camera attached like a big metal snake. Okay, so those are the things I wanted to introduce you to today. There are, I think what we'll do next is I'm going to move down to, if you have to get one of these, a little bit more about like access and the steps in getting to the proper diagnosis. So if they're going to use something like this, all the steps that are in play to make sure you get diagnosed correctly, which means you get on the right course of treatment. And then also public health and how we try to keep the population healthy and strategies that they take to educate people about potential health issues. Obviously, we have a huge public health crisis on our hands right now. And so that might be a little bit relatable to talk about that before going into all the other pieces we're going to talk about in the unit. So that's it for today. You're going to see there's not much attached to this. It's mostly the note for now. So getting that down. And then I might attach like one question for you to answer. And if I don't, then I'll pick up more on Friday. And we've got started. All right. So thanks, everybody. And I will talk to you Friday. Okay. And take care. Sorry, this was a little late. All right, later.